Hello, this is video number 2 for the bonus of Parcial2 of the course Modelos y Control de Producción. So we're going to talk about question 2 right now, in which we have a Kanban system with a Poisson of lambda is 6 units per hour and a lead time of 6 hours. And the questions are, how many Kanbans should we have in a system using the formula of Monden, and with this security stock that we were using, what is the level of service? So basically the formula we have is for the number of Kanbans is the demanda promedio, the average demand during the lead time. The average demand is 6, during the lead time is 6 hours, or 6 times 6 is 36, plus a safety stock, which is typically 10% of the demand during the lead time, which is 36, so the security stock should be around 3.6. And finally, we have to know the capacity of the container, which should be a bit less than 10% of the daily demand. And it was not completely, it is still not completely clear to me how to determine the capacity of the container. We could look at the container in phase I+1, which shows it has 3 Kanbans, but is this actually the capacity or not? Because it could be maybe 4 or 5 too, I don't know, but I heard afterwards that this might be the answer. Personally, I just took during the partial, I took 10% of the daily demand, so 6 units per hour times 24 hours times 10%, and then I rounded it down so it's lower than 10%. So n can either be 3 units or 14 units, and I want to discuss both options because it doesn't really matter for the understanding of the formula and how it works. So yeah, here I have the data stated. So the safety stock is 10% of 6 times 6, which is the demand during the lead time, which should be 36. And here we have the two options for the capacity, and if we take the formula, so D times LT plus the safety stock divided by N, we get for option 1 13.2 and for option 2 2.83. And if we round this up, which seems the most logical way, as you cannot have you need to have integer Kanbans, and if you go lower you have not as good, the results are not as good. So these are either 14 or 3 Kanbans, depending on the option you want to use. And then in question B, the question is, with the safety stock used, what is the service level? So we have used the safety stock of 3.6, and we can take a normal approximation, as we are allowed according to the question to use an approximation of the calculation. So we know the mean is 36, we know the standard deviation is 6, because the variance will be 36 and the square root of the variance is 6. As in a Poisson, the Poisson is 6 units per hour, so the variance is 6 units per hour, so over 6 hours, if we take a normal approximation, we can simply multiply both the mean and the variance with 6, and then we have a mean of 36, a variance of 36, and the standard deviation is 6 because it's the square root, and x is the 36 plus 3.6, which is 39.6. So if we fill in x minus the mean divided by the standard deviation, we get 0.6, and the inverse of the value of 0.6, if you fill in the normal distribution, is 7 to 5, or 7 to 6, sorry, 72.6%, which is equal to the service level. You could do this with Excel, you could also find it in the normal distribution table. So that was question 2. It was rather quick, so we used the Kanban formula with different types of capacities, but the usage and the understanding how it works is completely the same. And then we found that with this safety stock, this specific safety stock, we have a service level of 72.6%. Thank you.